Okay, so let's get started. Thank you to everyone in the audience for joining this panel on the future of always-on AI vision and the innovation roadmap ahead. We have a very exciting and distinguished group of panelists here for discussion. I'll speak a little bit about the topic, and then I'd like to introduce each of the panelists or have each of the panelists introduce themselves. Um, we will probably have some discussion among the panel, and we'd like to make this casual and interactive with the audience. Maybe we can try to save most of the audience Q&A and discussion for the last, say, 15 or 20 minutes. But feel free, anyone in the audience, if you have anything kind of urgent or anything especially relevant, to jump in before then, or maybe to chat, introduce something in the chat window. Otherwise, we'll get started. So my name is Jeff HENCKELS. I work for Qualcomm. I'm in Qualcomm R&D. My job is to help, from a business side, help develop and incubate our research programs to commercialization. For the past 6 years or so, I've been supporting, among other things, our always-on, ultra-low power initiatives around vision. So that it's been a long time in 6 years. We have, as many of you in the audience probably know already, Qualcomm has helped to pioneer this space, really at the frontier of innovation. We were the first to commercialize a battery, always-on battery-powered, always-on 4 battery-powered solution last year. So we went to market. We're already shipping the millions. We're in, among other things, the Ring 3 Plus doorbells. So Qualcomm has been a leader in this, and not just in the smart home, but in other areas as well, where we've been, we're pushing and commercializing across many different areas, and Qualcomm has become familiar with the needs and opportunities and in enabling solutions for those various needs and opportunities over these many years. And we're also, Evgeny here is on the call as well. His engineering team is now pioneering the next generation of always-on processing solutions, where we're achieving much higher performance and supporting, third-party CNNs, and maybe that can be part of the discussion as well. I've got a couple of slides to show, and then I'll the panelists introduce themselves. So just to give some context around this topic of ultra-low power, always-on vision and battery-powered devices. So, we know that that there is an imperative, right, around always-on perception and reasoning across all IoT devices. And of course, that includes battery-powered devices. And we know that we need to cross a threshold of, say, 1 milliwatt or so for battery power. I mean, the panelists can maybe provide their own perspective of what battery powered really means in terms of milliwatts. But we need to cross a certain threshold to allow intelligence. So in the past, we had PIR has been the only option for always-on visual awareness. And so if we want intelligent CV-based always-on awareness, we need to be able to enable ultra-low power. That's something that Qualcomm has done on the processor side. Himax is here represented on the sensor side, among others. And so we're making progress in enabling intelligence in battery-powered solutions. And we can see there's many billions of battery-powered IoT products to be emerging. So has a very powerful impact to enable always-on vision across so many billions of devices, across markets and use cases. It could have a disruptive impact, especially as we see here the value of vision versus other sensors, how important it can be. So, sorry, trying to advance slides here. So some examples, right? These are new use cases. We're not taking existing use cases and lowering the powers. By enabling intelligent vision, we're disruptively enabling an entirely new realm of use cases and markets. So, I talked before about Qualcomm's traction in the smart home. Same goes with XR. Say retail. We can do things like track inventory in an always-on way. We can do things with industrial gauges that weren't possible before. In automotive, the car engine can be off, but we can have an intelligent sense now, not kind of a dumb, movement-based motion-based sense, but rather an intelligent sense of the specific objects that are around, say, a vehicle, even when the engine is off. These are tantalizing new opportunities for IoT and for AI, and really excited to have this distinguished group of panelists to speak about these opportunities. So let me stop sharing now if I can, and I'll turn it over to the panelists. I'll start with, so our panelists here today are Tony Chiang from Himax, Edwin Park from Qualcomm, Pete Bernard from Microsoft, Evan PETRIDIS from EDA, and LJ Su from ABI Research. Maybe, Tony, we could start with you to introduce yourself and your organization.
Okay, great. Thank you, Jeff. So my name is Tony Chiang. I'm a Senior Director of Marketing here at Himax Imaging. We are a subsidiary of Himax Technologies, and our group, we design very low power, small pixel CMOS image sensors for consumer, multimedia, security, and automotive markets. We launched our first always-on vision sensor about 5 years ago, and we were one of the early entrants in this market. And we introduced our very widely adopted 320 by 320 sub-milliwatt sensor, and specifically used for edge vision applications. And since then, our product has been adopted in smart appliances to make sure that they're more energy efficient and more intelligent. We've been used in drones as well as HMI applications, and we've been integrated in several processor as well as open source platforms. Because we were so early in this market, we learned a lot about pain points and constraints when it came to battery life and system, and especially for cameras. And so through that learning, we of course developed partnerships, and as well as having a more system-oriented solutions approach, which drove a lot of our definition for our future sensors, which are becoming higher resolution. They're becoming smarter, more autonomous in terms of its own operation. And so we continue to drive that initiative. Now, our group, we're very active in tinyML. In addition to Himax Imaging, we're represented by other Himax groups. We have Intel Visual Sense, which is a solution company, as well as Himax Technology, which also provides processor. So we appreciate this opportunity to be part of this panel. Thank you.
All right. My name is Edwin Park. I'm a principal engineer at Qualcomm AI Research. I work with Jeff and Evgeny, and he's talked a lot about the product already. I'm the system lead for the Qualcomm always-on ultra-low power computer vision system. And our goal there was to create the lowest power CV solution out there. And we did this by approaching the problem holistically, looking at the entire system, from the sensor interface, obviously the digital that we produce, the models and the algorithms, and what our customers actually want. So we create a full end-to-end system from that. I'm also currently working on an exciting new low-power project, not necessarily ultra-low power, as the ones that Jeff talked about, but has far more compute.
Thanks, Edwin. Pete?
Yes. Hi, Pete Bernard. I run the Silicon team, Silicon and Telco team here in Azure Edge devices at Microsoft. So we recently announced Azure Percept. That's kind of one of our first offerings. The dev kit's now available if you want to buy one. And really what it's about is how to help our customers and partners develop and deploy edge AI solutions quickly and easily. And what we found was that there's an incredible opportunity out there, and the number of scenarios is kind of overwhelming about how, especially Fortune 500 companies want to kind of transform themselves using edge AI. But as we all know, there's lots of players and parts and pieces and things ranging from AI models and ML ops and security and other things that just need a path toward deployment, and a lot of customers need help with that. And so we're trying to build a platform for edge AI that helps do that. And of course, a lot of the things that we're talking about today around tinyML and ultra low power on the edge is something we're super excited about and look forward to getting more involved with.
Thank you, Pete. Evan? Evan, you're on mute.
Hi, everyone. My name's Evan PETRIDIS. I run engineering and product at a startup called Ada Compute. And we also exist in the solution part of the overall system. where it's a conjunction of hardware, software, and machine learning. And we're putting together application-targeted sort of solutions for machine learning at the edge, including the sensing piece and hardware and software integrated together. So, I think we're sort of trying to address something similar to what Peter's saying, which is that putting these things into production requires a set of skills that spans a big chunk of stack. And now we're sort of adding ML on top of that, which is the new piece, if you like, in IoT. And Ada Compute is trying to help people adopt that new set of technologies. And we actually also have a sort of development or proof of concept board called the AI Vision Board that's available on Edge Impulse and DigiKey. It's a much smaller scale in terms of power and cost, but it's very good for developing battery-powered or ultra-low power applications. And just in terms of my background, I actually come from the system side. So I've spent the last few years building large systems, IoT systems that include everything from hardware all the way up to cloud infrastructure and multiple cloud applications, millions of sensors deployed. So I've seen the need. I've been on the buying side of this equation. I've seen the need to have a better solution at these lower layers of how we can help systems vendors deploy these technologies. And that's what I'm hoping to do now. And I'm very glad to be here. Thanks, Jeff, for inviting me.
Thanks, Evan. And LJ.
Thank you, Jeff, for the introduction. So it's my great pleasure to be part of this panel. Hi, everyone. My name is LJ. I'm a principal analyst at ABI Research. So for people who are not aware of ABI Research, we are an emerging technology market research firm, and I'm the service lead for our AI and robotics research coverage. So at ABI Research, we mainly focus around market trends and opportunities that spans across all the edge AI domains. So last year, we have actually published a report looking at the tinyML market. And our forecast sort of leans towards a huge market potential for devices with tinyML chipset. I think our figures is sort of looking at roughly around a billion unit of devices by 2025. So we broadly categorize the entire market into three main use cases. It's around the first thing is ambient sensing. Secondly is the always-on machine vision, and then third is audio processing. So as Jeff has mentioned earlier, sort of the always-on machine vision is definitely one of the key use cases and sort of like the dominant application in this domain. So internally, we are quite excited with the market potential, and sort of I'm really keen to discuss more of the panel on the future development of the market. So yeah.
Thank you, LJ. So in thinking about the topic of the panel, the innovation roadmap ahead, right? The evolution of always on AI. Maybe we can start with that market potential that you're talking about, LJ. Evan, you talked about the buying side. So if we think about, where the use cases are, where the commercial market opportunities are, where the dollars are, which areas are driving say investment and focus on all stuff, on the solution side and the deployment side? Where are the areas that are really driving investment now and solutions now and going forward? How do you see that? I'll throw that out for the entire panel for whoever wants to speak first.
I can go first. Because for our side, we have been engaged with a lot of commercial projects. And so at least in terms of near-term uptake for market opportunities, so we see for always-on vision would be to enable devices like computing devices, laptop, notebook, for example, battery-powered cameras, and then also intelligent appliances that are required to be more energy efficient than before. We will key vision a way to extend battery, which is critical for these devices, but also to deliver more seamless and natural user experience for these devices. And so we see the most near-term uptake and adoption in those market areas.
Yeah, I mean, I would add to that we also have seen, I would say near-term interest. I don't, the adoption is still early, but near-term interest in retail and also in certain sort of industrial applications, factory style, particularly around safety use cases and that kind of thing.
Yeah, we've seen a lot of interest. Usually, there's it's kind of a series of problems that need to be solved, at a given site, and typically a commercial customer of ours will combine lots of different hardware, to solve that problem. Sometimes it's AI gateways, sometimes it's high definition cameras, sometimes it's motion sensors, very simple sensors. And so this is like an extra tool in the toolbox. If you have a low power AI vision sensor, you now have the ability to do, 2 or 3 more really interesting scenarios on top of all that other stuff that you need to deploy. And that could be, visualizing inventory on a shelf, or that could be, reading analog gauges, or it could be sort of keeping an eye on something for kind of like physical anomaly detection, or like physical asset protection to see if anything's been disturbed. So it's kind of like another tool in the toolbox. We haven't seen a lot of customers say, well, I'm going to use just this sensor and now I'm going to deploy that. It's usually part of a broader portfolio of parts that work together. But it certainly brings a whole new kind of set of things, especially if it's something that doesn't require any infrastructure to deploy, right? So if it doesn't require any cabling or, no wires, peel and stick as we call it, all of a sudden then the deployment costs become a lot less. And then the opportunities to deploy a lot more of them, increase dramatically because, at the end of the day, it's an ROI for the whole thing. And the really nice thing about like kind of this low power vision technology is that you can radically reduce the deployment costs and relative to sort of traditional edge AI hardware.
I'd like to add on top of that what Pete said. I mean, in a lot of these applications, you do have cameras, let's say in retail, that can look at the whole store. But until you get to ultra low power vision, you won't be able to look at individual items or individual shelves or individual piece of equipment until the device gets small enough, cheap enough, and lasts long enough without power directly attached to it.
Yeah, so if I may, I will just add on to what the panelists has said just now. So I think since COVID, I've noticed probably 2 major trends. So obviously, there's a lot of short-term opportunities within the consumer device sector, and that has always been sort of like the main driving force for tinyML adoption. But particularly with COVID, I think there is an increasing interest around smart building. So when I say smart building, I'm talking about occupancy detection, perhaps crowd management, sort of cameras that's being deployed to either detect PPEs or to detect sort of the safe distancing or to implement certain distance between employees or customers within the store. That is sort of like the impact that is driven by COVID-19. But I think at the same time, I was also intrigued by the opportunity where I think the whole ethos around tinyML is the fact that it is optimized for battery-powered devices. And I think from my perspective, battery-powered sort of carries the meaning of it being able to be mobile as well. So I think any mobility or sort of mobile-centric devices such as robotics and drones could also benefit from this, because I think one of the key use cases that I've seen popping out a lot is sort of indoor positioning for AGVs and AMR, and sort of having that tinyML sensors that's being able to play as a supplementary role to whatever main sensor that you have. Is either the main RGB cameras or LiDAR or radar. Thus comes in handy as a sort of like a fallback mechanism, a safety mechanism for robots.
Yeah, I find it interesting. I'm glad you all mentioned battery powered specifically as kind of primary opportunities and imperatives driving investment. That's something that I've seen at Qualcomm as well. Just to clarify, and to me, that's really where the impact is, enabling for the first time, crossing the threshold of battery powered and enabling intelligence for the first time in battery powered. And so from your perspective here in the panel, what does battery powered mean? Just to clarify for the audience. I mean, at what level, where is that threshold of wire free?
I don't think there's one answer to that, but I've got a way to think about it, which is, I kind of think about if you have battery powered devices, whether it's actually going to be viable is sort of dependent on the ratio of human carers to devices and how much love they get. So if you take your mobile phone, it's kind of 1-to-1, and you treat it like a pet. So you look after it every day, you charge it up, and it gets a huge amount of love from the human. But if you've got, you know, 1 million or even, you know, a few thousand sensors in a factory, and you're talking about battery powered sensors, you know, that's now at very best it's like a flock of sheep, and then you know you need a herd of people running around, you know, looking after the things. So you know, whereas we can put up with a battery life of 1 day for our mobile phone, and maybe it's, you know, 1 year for a domestic fire alarm or domestic sensor or one of these, you know, smart doorbell type thing. 1 year is going to be absolutely useless in an enterprise sort of environment. You know, really, you need the life of the device, honestly, in that sort of environment. 10 years, you know, 5 to 10 years.
Yeah, I mean, yeah, we use a year as a baseline. Yeah, because it's about cost. And so, you know, if you end up with the battery life being a few months, now whoever deployed that at Walgreens, that employee now has to go spend time keeping those, you know, recharging those things or getting new ones or whatever. So now all of a sudden the cost of maintaining the system goes up as the battery life goes down. So we look at a year as a minimum. I agree though with Evan that, you know, ideally what we want to get to is lifetime of the device. So 5 to 10 years, or have some opportunity for it to be a self-powered device. So there's some sort of solar or light harvesting or backscatter harvesting technology so that you deploy it and it's essentially, that's it. There's no maintenance on it. There's no cost of maintenance once it's deployed. That's kind of the ideal. I don't think we're there yet, but for us, if it's less than a year, then it's really nothing interesting for us.
I'd agree with that, Pete. I mean, the right answer is energy harvesting. That's, you know, and that is the technology. I think you're right. Except for very, very simple things, we're not there yet, unfortunately.
So what's next? I mean, we talked about, look, there's interest in a number of different categories. We talked about, you know, there's commercial traction. We know that there are, you know, now always on for battery powered processing solutions, or, you know, always on sensor solutions. You talked about, look, there's multiple pieces to the pie, Pete, you know, and so what's missing from then an innovation standpoint and from a system standpoint across all these dimensions?
I can go again.
Sure.
I'll buzz in. You know, the other thing, just as I mentioned before, these are usually deployed as part of a bigger system. So you have to think about, from the customer's point of view, they are deploying and managing a system of edge endpoints. And that means, you know, provisioning, management, updating, security, MLOps, all that stuff needs to be done in a pretty universal way. And so one of the things we're trying to do is working like with Qualcomm and other folks to integrate AI tool chains and other things into Azure so that, you know, it's a little easier to provide a single pane of glass to a Walmart or somebody who needs to manage all these things. The last thing you want to do is sort of force a commercial customer to sort of, you know, go through 4 or 5 different processes to do FOTA here and this here, and then, you know, that's just not going to work. So just think about what you're doing as part of a bigger system. Or is it updatable? Is it, you know, does it support like secure transfer of ML models that can be decrypted on the device? That's a big thing. You know, can it be easily provisioned and deprovisioned? So you just got to think about the deployment and maintenance of these things. Once you've kind of done, I mean, we sort of like say, hey, we're just going to count on Qualcomm and other partners to do crazy stuff with low power silicon. That's awesome. But then it's like, okay, do you want to put it in a device and deploy it? Now it's like, we got to solve all these other problems. So it's just something to think about up front, is like, how do I make sure that this thing can be a good citizen, you know, in a deployment for a commercial customer?
I think ultimately for a lot of the commercial deployment, you also kind of need to think about how you do versioning, perhaps testing and validation ultimately, because you kind of also need to monitor for perhaps drift in your AI model. And then once you discover that drift, how do you then sort of do the retraining and sort of redeployment process? That could be kind of a headache if you kind of think about the fact that some of the corporations out there does have, as what Edwin said earlier, thousands or millions of devices that runs on, I guess, different types of accelerator or GPUs supporting AI model, and sort of how do you navigate through all that complexity and sort of, I guess, providing a single pane of glass, as what Pete said, to the enterprise. I think that is something that enterprises find very, very valuable nowadays, which is missing from the market right now.
Yeah, I mean, I think the thing I'd say is even, of course, you know, the end customer doesn't want to know about all the gruesome stuff about how you build this stack. But even you know, I kind of come from a large-scale system vendor in my previous role. And even for us, so that was IoT, and we didn't have any edge AI, but we had everything else. And just maintaining an engineering team that could do everything from, you know, device level security to hardware to protocols to local DSP to, you know, all the ingestion stuff and apps is an immensely complex engineering management task, and it's difficult to get the right combinations of people. And of course, the platforms like, you know, the Azure type things, or the platforms on the cloud side are helping a lot of that. But there's still, for any given application, there's still a lot of engineering work to actually create a solution that can deliver value to an end customer. And now, so, you know, you asked about sort of pain points, I think, Jeff. Now we're saying, okay, as well as all of that stuff that you need for these fleets of devices that we've had for IoT for the last 10 years, now we're going to put ML on top of that, which is its own very specific, you know, skill set. As we all know, it's quite different to traditional engineering approaches. And we're going to cram it down into these small devices. I actually think that just how you get those engineering teams and how you build out that piece of the stack and how you integrate it in is a huge pain point. And I think, you know, that's what I'm hoping that we can do, help Data Compute to help system vendors to navigate that. You know, it's a gap. It's that gap which the silicon guys are very well aware of between. We've got fantastic silicon. I mean, you guys deliver. You know, you deliver. You know, Tony, with these cameras I've been looking at, they're fantastic. So, you know, at that level, we've got the underlying building blocks, but there's just so many different pieces that need to go together to actually make a valuable proposition that I think it's a real impediment to you know, sort of getting this out there, democratizing it, if you like.
So that's a great point, Evan. And related to this point, what is the missing piece there? Is it like the system integrator type of companies who will just do this, or the end users themselves, they will have to hire and build these teams to work on solutions? Because as you say, the Microsofts are going to provide all these greatest tools with all the security and other things, right? Qualcomms are going to make like billions of silicon, and you guys too. Like, how do you connect all of this into one kind of thing?
Yeah, we see ourselves now as a subsystem vendor. So we're kind of going after that, after trying to bridge that gap. So I hope that we can work out a route to market that will help to bridge that gap. That is exactly what Data Compute is doing. You know, you comment on, I think you comment on the end customers. look, even for systems vendors, it's hard enough. You know, people who build hardware and software and everything, they've got their hands full. So it's pretty tough. It'll take a few years before they get to the point where they're efficient at absorbing this new technology, I would say.
And just to follow on to Evgeny's question, I mean, what's hard about it? We need to build out a value chain. We need a broader system solution, and you know, so we have more of a turnkey, you know, solution for all markets. You talked about ML and AI being a particular pain point, Evan. You know, being a long pole. That's hard. Are there any other elements that are particularly challenging at this point that look like they're long poles that would be difficult?
I can add to that. I mean, a lot of the ML is data. So most of the customers don't have data, don't have a good way to know what they want from the final solution. I mean, is it you want to detect the people, or you want to detect something that's happening, and all the crazy conditions that the object itself could be in. So it's data, the understanding of the data, and the annotation of data to train the model. And in training the model, at the end of the day, tinyML is ML, and a lot of the verticals just don't have that capability. So either we have to provide that platform, some type of integrator needs to come in, or something like what Pete's talking about, having a solution that could train without their having the full ML expertise that this audience would have.
It's a tendency whereby a lot of data, even though they are there, is siloed as well. So especially when you're deploying something of a system with a multiple end nodes or multiple devices, it tends to get pretty complex when you try to sort of piece the entire picture together. I have come across vendors who sort of do offer just a very simple IoT platform that also enables the onboarding of AI models. I think that's probably one of the easier entry point to sort of facilitate enterprise to deploy AI model. But sort of even that, the enterprise themselves also need to figure out what do they want to do with ML, how do they get the right data, and then how do they then train and deploy the model. So yeah.
So Edwin, you brought up a very important question on the data. I'm just kind of thinking about some of the points that I think Facebook made earlier today on the on-device learning. I mean, is it reasonable to assume that in the near future, like in the vision space, these devices will be capable of doing some on-device learning versus kind of doing training off device and then downloading the models? So like federated learning, those things. So Pete, do you have any ideas like what is happening in the Microsoft labs on the on-device training and learning and federated stuff?
Well, you know, it's a trade-off of, you know, is there the horsepower, is there the memory? You know, we just talked about battery life, you know, so obviously that's kind of working against you there. So I would say on-device training, you know, I don't know if we're not there. You know, especially most of these are going to be connected to the cloud, if not continuously, then occasionally. And so if you're connected to a hyperscaler, then, you know, why wouldn't you leverage that for a lot of your, might be out of the 100 that you've deployed, you can associate 2 or 3 of them to gather some data and then use the cloud to, you know, retrain. But sort of, you know, because then if you retrain that one device, then, you know, there's other devices too. So now you have to get that model off that device and then to these other devices. It's just really complicated if you think of it as kind of just training on the end device itself. It needs to be part of a bigger system. So, you know.
Yeah, you still need to have data sets.
Big data sets, yeah.
Something to Evgeny's point, I mean, there could be devices that is connected to power that could either collect data or train data and push that back up.
Yeah,
it's power. I mean, broadly speaking, if you want something on the order of an ear, at the smallest battery, you have to burn about 1 milliwatt. You know, when you start talking multi-cells, you're talking 3 to 5 milliwatts. When you're talking these D cells, you're talking about 8 milliwatts. And that's about it, right? So that's including the communication power, potentially any new models that get updated. And you quickly eat into that budget. It is conceivable to download new models training. I think unless you get to the larger batteries or something that's connected, would be difficult. But as a platform, I mean, you could train. From a power budget point of view, at this time, until we get some harvesting capabilities, it may be a little difficult.
Or you could have some of the units deployed could be actually powered
Yes,
and
yes,
designated as like training endpoints, and then once a month you could run them through a process to sort of help retrain things, and then go up to the cloud and back out to the other 98 units that have been deployed.
Edge computing changed the discussion a little bit.
So I think we identified 5 or 6 really fascinating and compelling market opportunities, right? If I was going to start a company in this space, there would be some really interesting areas to explore. You talked about building blocks, Evan. From the sensor building block point of view, Tony, what are the pain points that you see in Himax's kind of innovation roadmap going forward? Where are the pain points in sensors, and what does that look like in the future?
Well, actually, so a lot of the pain points themselves are actually very much system related. First thing, in terms of mass consumer adoption, first of all, is privacy. There's still an uneasiness when it comes to first camera that's always on, collecting a substantial amount of data, and then they don't really know what's going on. It's edge computing. It's whether it's computing locally or it's computing it in the cloud, and so there's a bit of concern in terms of privacy. We try to address this concern by having different interfaces, dedicated interfaces that are for video stream, as well as dedicated interfaces that are just dedicated for these computer vision type of applications. We try to have local processing, and we talked about that a little bit. We try to have local processing to make some level of decisions so that we do not always have to transfer the data off the sensor. And then, of course, we support hardware privacy mode so that hardware switch, for example, can be employed. And so a lot of these are actually very much system driven in terms of what the OEMs themselves, as well as what the consumers are willing to accept when it comes to privacy, what type of data, how much data, where this data is going to go. And that's been a really big pain point that we're still trying to solve at this time. Another pain point is additional cameras. And so some of the devices that we talked about, whether it be mobile, wearable, computing, the real estate is a premium when it comes to cameras. And so whether they can accept having a second camera being installed or potentially be a third or fourth camera being installed, that has been a big question when it comes to the industrial design and the form factor. If you use a secondary camera, for example, whether that secondary camera, if it's meant to trigger a primary camera, can actually have the field of view perfectly aligned to the primary camera so that it provides relevant trigger information. And that's been a pain point. There's other things like data overload. So image sensors provide a lot of data. And so current solutions, we try to make the data sparse by reducing frame rate, supporting deep level pixel binning, having a very flexible region of interest readout. But there's still a lot of work that's needed when it comes to compression, quantization, and pre-processing, so that we can actually integrate more on the sensor side. You need to provide.
Yes, yes, Zach, I'm here, and actually I'm doing a bit of more stuff. That's where.
Tony, are you done? Anything else?
No, actually, there's a few other pain points I was just going to mention really quickly. So there's also camera interfaces. There's a lot of openness in terms of what camera interfaces to converge to, whether that be CSI2, whether it be a standard digital interface, even I3C right now is something that we're driving along with the standards body to support I3C going forward for these type of use cases and application. And so different interfaces and non-standardization of interfaces also have been a pain point when it comes to integrating sensor to different types of processor. And the last thing is just right now there's a more of a lack of a solution approach, and I think that's really where a lot of the development and innovation is going to go. Is that processors are doing pretty well, machine learning is doing pretty well, sensors we're getting the power down, but we still, at least in our initial pain point, is that we still need to have a really cohesive system integrator who can really develop a more tightly coupled approach when it comes to being more intelligent about how you control the sensor, the different levels of handshake, the amount of data that they would like to consume. So the system partitioning right now, I think, is not optimal. And I think that's where a lot of the work needs to go, is for a system integrator or to really come in and drive a lot of the definitions about system partition. So that's and so companies like EMSA, for example, which is part of Himax, that's one of the initiatives. Is really looking at everything from a solutions, and then looking at the components and then trying to integrate it as tightly as possible to get the lowest power.
Super interesting. Yeah, some consistent themes emerging from our discussion so far. Edwin, how about you? Tony talked about local processing. What does that innovation roadmap look like ahead?
Oh, well, first of all, we already talked about data. I think second of all, I don't want to say it's easy, because it's not easy and it's definitely not cheap. A lot of the edge solutions out there are not at the latest semiconductor node. So just getting to a semiconductor node that looks more like a cell phone or even modern day processors lead to a lot more compute power at lower battery power. And actually you could get a combination of both, more compute power at a lower battery power, just by going to the latest node instead of being something that's 4 or 5 years or even 10 years behind, as we see a lot of the edge devices are at right now.
Yeah. Can I chime in on that one? Yeah, I agree with that. And, this is one of my personal complaints, actually, which is that, one of the problems with many of these kind of market segments is that, early in the market segment, there's not a massive volume, as we all know. And all the, one of the things that you see in the tech industry is that the power of the mega applications, and there's plenty of guilty parties around this, but you could look at Intel with main CPUs, or there's many of the big players have got this issue, which is that the coolest and best technology, as you are talking about there, is really applied mainly to the very high volume runners. These mega applications could be cell phone chips, could be PC chips, or whatever. And so if you're in a more nascent market, like we essentially are all talking about here, where you might have you're starting with a few tens of thousands of units, and then you're going to your hundreds of thousands, and you're hopefully going to get to your millions of units. It's actually quite hard sometimes to get the right engagement from the ecosystem. And, everyone here obviously is making efforts around doing that. But as someone who, spent a lot of time talking to component vendors, I think the technology is all there, but my access to it is actually patchy, I would say, at best.
I like that.
I would. Oh, go ahead, Tony.
It's not just your access to it. It's the fact is the investments, like what Edwin was saying, the investments to use the latest technology to address, to deliver the best image quality, the lowest power consumption, very low leakage SRAMs. Those take substantial amount of investments. And so you're right. So we of course, even when we started in this market, we use an older, stable, high volume, low cost technology to address the market so that we can start developing out the ecosystems, the solutions, and all the pieces. As the market grows and mass market adoption begins, whether it's in mobile computing spaces that already ship in hundreds of millions, then we can start making these larger investments towards using a 2D or 3D stacked die, for example, and to be able to deliver the best quality. And then that allows us to also support higher level pre-processing on our chip, make better decisions on the sensor itself, for example, to support these privacy modes that we discussed. But all of that requires a multi-step approach. And so we're I think, grown quite a bit in the last 5 years. I think we're on that verge of mass market adoption where we can start looking at making these investments. And so we're still, but we're close, and I believe it's going to happen soon.
Yeah, I mean, people like Himax, it's very clear that they've had a long-term view about this, and that's a bit of an exception. There's a lot of people who aren't here in this room, actually, who have technologies that would be, quite applicable, and it's kind of complaining to the wrong people, but it is definitely an impediment. I mean, I think that is a thing that slows things down.
Yeah, I was just going to say that I think the part of what impedes kind of unique or innovative technology is the cost of adoption. So, in as much as people can make their technology have a zero cost of adoption from the commercial market or whatever, then it's going to be adopted that much more quickly. And there's trade-offs there. Maybe you can't do exactly everything you want to do. But introducing some kind of new systems or new processes that have to be adopted just to use the tech is going to throw the cost of adoption through the roof, and then you never ship. So it's sort of like you got to sort of you got to just really think of the from the customer's perspective. How can they adopt this with virtually zero cost based on what they've already invested in?
Outstanding. Yeah, fantastic discussion and feedback. I want to reserve enough time for audience discussion and Q&A. We only have 13 minutes left, but maybe I'll ask one last question. Does anybody want to throw out, say, 10 or 20 seconds of bold predictions of what we might see in this space over, say, the next 3 years?
I've got one. I reckon that somebody will come up with the residential equivalent, something that everyone has to have in their house, kind of like your Alexa or Google Home style thing, but with this always-on sensing.
Yeah, just to echo that. Sorry, LJ. Just to echo that.
No
I mean,
worries.
I believe that all of our homes will have a sense of how they're occupied by humans at all times across the house, so that passively your lights will follow you around, your music will follow you around, your Wi-Fi will follow you around, your blinds will open and close. All that should happen automatically. Definitely always on presence detection in the residence will emerge eventually. Sorry, LJ. Go ahead.
No worries. Yeah, I think right now we are seeing mostly just a single AI chipset for a single device. But I think with tinyML, you will see multiple AI chipset on a single device. So sort of like forecasting shipment will be extremely difficult for analysts like me. But it will be a big market for everybody else because now you are talking about a system that has multiple decision-making systems that is doing different stuff on a single device. So, yeah.
Right. Yeah, I agree with that. I think vision is really just one sense, one type of sensors, and I think Paul already alluded to the fact that probably there is obviously a lot of different types of sensors, audio sensors, infrared sensors that collect different informations to really provide you a broader breadth of what the context around you is, and then to be able to put all that together and then couple that with tinyML, and then be able to multiplex and do it all within a single system so the cost can remain low. I think that's really where the direction is going to be in 2 to 3 years. I really believe that's going to happen more and more often.
Awesome, thank you. So let's turn it over to the audience. If anyone has any questions, please feel free just to chime in. I see Abkal has sent one private message, so feel free, Abkal, to jump in with your question, or if anyone else has a question, please unmute yourself and go ahead.
Yeah, it's just a contribution, not a question.
Okay.
It's just a contribution. Can you hear me now?
Yeah, go ahead.
Okay. It's just my observation. Here in Africa, this is where we have huge energy challenge. We have big energy issue here. So for me, the edge AI systems are mostly needed here for so many use cases. We have need of them here. But from everything happening is like Africa is cut off from even everything, from the planning, the people participating, everything. But we need them here because we have so many problems here. I've seen use cases where we can deploy some of these things. For instance, this one, there's this ultra low power compute vision from Qualcomm, UCC 112. When I listened to the presentation, I realized that I noticed that we can actually have need for it here because kidnapping is high here. In the northern part of Nigeria, kidnapping is there. Students are being kidnapped from their schools. So if we have this in schools, it can monitor whatever is happening. And then even women working at offices, they leave their children at home or at daycare centers or at crèches. We could also have this as a kind of child monitor. So we have so many applications we we can come up with here. This is
Thank
just
you.
one example.
Thank you,
Yeah, so
Rosalind. Yeah,
for
great
health,
contribution
yeah,
to
for
know
health
that.
issues, okay, for health, we also have need of it. Like we have disease prediction, different kinds of disease in health monitoring. So we have a lot of things to do. This is where the market really is, and I don't know why nothing is being looked at in our own direction. That's just my
Thank
contribution.
you. Yeah, wonderful. Thank you. A lot of use cases and applications, especially in energy scarce areas such as Africa. It's very exciting to know what impact lies ahead for this type of innovation. Thank you. Anyone else have any questions? Go ahead, Pete. Sorry.
I was just going to say, I think to her point, I mean, one of the things we haven't talked about is the importance of low power networks connected to these sensors. So leveraging NB-IoT and LoRaWAN and some of these other things, and I'd mentioned self-powering before, but these types of sensors are good solutions for areas that are remote or underserved by kind of traditional infrastructure. So now I'm not sure if it's not going to nail every use case. It's not a replacement for a security camera, but certainly the combination of low power networks, self-charging or self-powering, and these sensors can put all kinds of really interesting scenarios out into communities where they don't have the same level of infrastructure as kind of other markets.
Yeah.
Yeah, and the energy harvesting thing, the one place that actually is practical now is if you're outdoors. And you can stop a reasonably small, and the solar cells have become dirt cheap now. So reasonably small panel and a modest battery, and you really can make that work, with zero maintenance more or less forever. So that's the one subset where it is actually really a nice match.
Yeah. So there are many things that could be done, but the problem now is there's nothing happening here in terms of edge AI in Africa. Nothing serious is happening. So I don't know how the tinyML community can get us involved, because we need to run along. Applications need to be developed. The market is here. So I'm using this opportunity to say you should look towards Africa and work with us. For instance, I'm a lecturer at the University of Lagos. So I'm a researcher there in the Department of Computer Science. So we can do a lot. And then the market can come here for development, for businesses. A lot of opportunities are here.
Thank you. Any other questions?
Jeff, this is Amit. I have a question related to the application for ultra low power vision with respect to AR, VR. I think right now, all the discussion that you guys have was very valuable. And I think even Pete and Tony kind of brought up the cost of deploying the technology that we have access to develop through mobile and other investment. Right now, there isn't such a large volume of application that at least I can see, except AR, VR in coming future, that can really drive some of these developments. But I didn't see that being discussed in this panel. So I just wanted to hear opinion from you guys. What are you guys seeing in terms of AR, VR space for tiny vision? Because for eye tracking, SLAM, and other applications.
Anyone else want to go? I have my thoughts on this I can add, but I'll invite the panel to comment first.
Earlier today, we had Ravi, actually, one of my coworkers, present on this with some of our devices. I do agree with you that that is an interesting application, especially if you include the sheer number of cameras on these devices. So even if the market is moderately sized, the number of AI inference engines and cameras that will have to support, and the power is, X times larger than the number of devices that will be out there.
Yeah, I mean, in my opinion, I think XR is still small. I mean, not that small, but still small. But in my opinion, it's actually a perfect use case for tinyML and for always-on vision, because, as Edwin said, you have quite a few cameras on your headset or your AR glasses. But you're really constrained by power, form factor, and thermal, and all these kind of things. I don't think there is any other solution there to be kind of fully capable of doing all these tasks. I think definitely we are going to see a lot of activities in this space, and vision is going to play a major role there. I think that's why Vikas gave this presentation, keynote presentation this morning, right? And that's why I think Facebook has like thousands of people working in this space. It's like it's a big bet, but I think definitely the always on vision is going to play a huge role in XR to make it successful.
I mean, just to be clear, the very, very tiny power envelopes that future AR glasses have. So, and this is an area that we're going to see hundreds of millions of units sold per year eventually, right? So the question is when. But there's no question that AR as a market is hundreds of millions of units. But that's not the only one. I mean, I outlined a set of markets earlier, and each of them is hundreds of millions. Toys. That's hundreds of millions of units, and that smart toys that will have always on, battery powered smart toys that will have an always on awareness of what's around it. That's hundreds of millions right there. XR, many hundreds of millions. Smart home, hundreds of millions. Retail, hundreds of millions. Smart city, hundreds of millions. Automotive, that's about 100 million a year. All and but with multiple, solutions inside. So 100 million cars, each with multiple always on. Battery for, when the engine is off, always on cameras. These are all very, very high scale markets that the question is not if, right? There's billions of units here. It's just a matter of when and how, and what are the impediments that lie in between, and how are those getting solved by the value chain that we outlined here. But to me, there's no shortage of opportunity. This is going to be pervasive, right? And many billions of units sold across, the hardware and the AI and software. There's so much that needs to go into it, as we discussed here. Solutions inside. So 100 million cars, each with multiple always on, battery for, when the engine is off, always on cameras. These are all very, very high scale markets that the question is not if, right? There's billions of units here. It's just a matter of when and how, and what are the impediments that lie in between, and how are those getting solved by the value chain that we outlined here. But to me, there's no shortage of opportunity. This is going to be pervasive, right? And many billions of units sold across, the hardware and the AI and software. There's so much that needs to go into it, as we discussed here. Any other questions? Any other comments from the panel?
No, I thank everyone for their time. I actually do need to drop for 1 o'clock, so
Yeah.
I need to exit here.
All right, see you, Pete.
All right.
All right. Well, thank you very much, Tony, Edwin, Pete, Evan, and LJ. Really appreciate fantastic, outstanding discussion today. Thank you to the audience as well.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors. BrainChip. Babel Labs. DSP Group. Edge Impulse. EMSA. Gray Matter Labs. Greenwaves. Himax. Imagimob. Latent AI. Maxim Integrated. Quixo. Reality AI, SenseML, Silicon Labs, Sentient, Google TensorFlow, XMOS, and lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.